Hey everybody, welcome back to another one-dimensional kinematics video. This time we're going to be looking at velocity time graphs. Okay, so the graph below shows the velocity of a train as a function of time. A, at what time was its velocity the greatest? B, during what periods, if any, was the velocity constant? C, during what periods was acceleration constant? And D, when was the magnitude of acceleration the greatest? Okay, so here's the graph that we're looking at here. Okay, we'll go through them one piece at a time. Okay, so we've got our velocity along the y-axis measuring in meters per second, and along our x-axis we've got time measured in seconds. Okay, so hopefully you've got a good focus there of the graph. Okay, so let's go through this one by one. Okay, so I'm actually going to slide the graph up here just a bit, and then we'll go through these problems one at a time. Okay, trying to get this the location good. There we go. Okay, so part A, at what time was its velocity the greatest? So here's the thing, since the y-axis is measuring velocity, okay, we just look at the highest y value on the graph and connect it to the corresponding x value. Okay, so the highest y value seems to occur right around here. Okay, so right about here, at this point right here. Okay, and we want to find out what x value that corresponds to. Okay, so if we actually drag that down, it looks to be approximately 47 seconds. Okay, so I think that might be a fair statement. So for part A, okay, at what time was the velocity the greatest? At around t is approximately 47 seconds. Okay, now you might get plus or minus 1 point. That's okay. Okay, again, this is based on our eyes, so our answers might be a little bit different. Okay, so part B, during what periods, if any, was the velocity constant? Okay, so this is a velocity time graph. Okay, so velocity is constant when the slope is constant. Okay, or rather the slope is 0. Okay, so for a velocity time graph, the slope must be 0 for it to be constant. In other words, it should not be changing. Take a look at this. Okay, so from 0 to 47 seconds, the velocity, the y values keep increasing. Okay, so this is not constant velocity. Okay, here the velocity values are decreasing. This also cannot be constant velocity. Right around here, okay, so between about 90 seconds to about 108 seconds, you have a horizontal line. The velocity is not changing. In fact, it looks like it's very close to 0 or 0. Okay, so this is the only time through which the velocity is actually constant. Now, you might argue, hey, well, technically the slope of this graph is 0 up here, right, because you've got a peak. Now, you could argue that, but it's asking for a period of time. This turn happens in an instant. Okay, so that's not technically a period of time during which the velocity is constant. It's just that instant from when the velocity changes from increasing to decreasing. Okay, so we're not going to count that point. For B, the answer is the constant velocity occurs between t is approximately 90 seconds to t is approximately, well, I guess here it actually looks like it's about 108 seconds. Okay. All right, part C, during what periods was acceleration constant? Okay, now remember we're dealing with a velocity time graph. Okay, acceleration is the slope of a velocity time graph. That's very important. Okay, so if you don't have that, write it down. Acceleration is the slope of a VT graph. Also, a little note on the side as well, in case you did not know, displacement is the area underneath the velocity time graph. Okay? So just so you know, you don't need to know that for this, but a lot of information can be gathered from the velocity time graph. Okay, so let's shift this up a little bit. Okay, so acceleration is the slope indeed. So when is the acceleration constant? Well, okay, since the slope measures acceleration, wherever the slope is constant, that's where the acceleration is constant. Okay, let me just shift that down. Look at this. We've got a constant slope. Here it starts curving, so it's no longer constant at this point. Right here the slope is decreasing, decreasing, decreasing until it hits 0, and then it starts getting steeper and steeper and steeper until it reaches a constant line here. Okay, so we've got a constant slope up here. So if you actually take your pen and you draw a line down, it looks like it starts curving right about here, okay? Because this is where the arch happens. Okay, so that's about 38 seconds. And let's see, the other arch is occurring about maybe right around there. Okay, so that looks like you can approximate it to be 57 seconds. Okay, so between 0 and 38 seconds, between 57 seconds and 83 seconds, right? Because don't forget, it's going to start arching here again because it's changing. So somewhere around here would be a safe bet. So between 0 and 38, 57 to 83, and then here obviously it's not changing, so acceleration is constant. So between 90 seconds and 108, just what we had before. Okay, so for part C, there's actually 3 different locations. Okay, so the first is between t is approximately 0 seconds to t is approximately 38 seconds. Okay. The second area is from t is approximately 57 seconds to t is approximately 83 seconds. And the last part, let's just put that away. The last part 3 is from t is approximately 90 seconds to t is approximately 108 seconds. Okay, so 3 different parts. Remember, acceleration is the slope of a velocity time graph. If the slope is constant, then so is the acceleration. Okay? Now, part D. When was the magnitude of the acceleration the greatest? Okay, because slope represents acceleration, the greatest acceleration will occur when the slope is the steepest. Okay, so just looking at this, you can see that the steepest slope is occurring here at this half of the dip, right? But we have to go with the part that's constant, right? So that's between 57 and 83 seconds. It's a straight line. Therefore, the acceleration is the largest when the slope is the steepest, which occurs between 57 and 83 seconds. Okay, so let me just shift that up a little bit. Okay, so the largest acceleration occurs when the slope is the steepest. And this occurs from t is approximately 57 seconds to t is approximately 83 seconds. Again, maybe when you look at the graph, you see a little bit different values. That's why I'm using the approximate symbol. Okay, yours might be plus or minus 1 or 2 seconds. That's okay. Overall, that's it for this video, guys. If you enjoyed it, be sure to subscribe to my channel so you can catch my next video, and give that like button a click if you don't mind. Okay, I will see you guys next time.